Hello, this is Adam Paulson welcoming you to this bite-sized bio webinar, which today is sponsored by Eppendorf. Eppendorf is a leading life science company that develops and sells systems for use in laboratories worldwide. The product portfolio includes pipettes, pipette tips, centrifuges, mixers, ultra-low temperature equipment, and more. Today's presentation is titled Automate Your Pipetting, Unleash Your Potential, and is being presented by Dr. Jessica Wagner from Eppendorf. Jessica is application specialist focusing on automated liquid handling at Eppendorf SC in Hamburg, Germany. After studying biology at the universities of Marburg and Düsseldorf, she started work towards her PhD with a focus on reproductive biology at the medical school Essen. She joined Eppendorf in 2012 as application specialist for cell handling and workflows, sharing her knowledge in seminars and user workshops around the world. As always, we will have a question and answer session after the presentation, so please type any questions that you have into the questions box, which appears on the top right panel of your screen, and I'll put them to Jessica at the end. Details of how to access the on-demand recording of this webinar will be sent to you by email shortly. So now over to you, Jessica, for the presentation.
Thank you, Adam, for the introduction, and welcome everyone also from my side, and thank you for joining us today. So let's start with the presentation. Today we are looking into liquid handling automation and the applications and workflows where automated liquid handling platforms or systems can support your daily work in the lab. So why automation? What are the true benefits of automating a workflow or even part of a workflow for that matter? The first thing that probably comes to your mind when trying to answer this question might be throughput. With increasing sample throughput, the benefits of automation becomes quite obvious. The more pipetting steps a protocol or workflow includes, the more likely it is that errors occur when pipetting by hand. Repetitive steps can become tedious with time, leading to decreased concentration and focus of the operator and therefore increase the risk of introducing errors. Another benefit of automating pipetting tasks is that it gives you the time and freedom to do other things in the lab. You still need to invest some time upfront for programming and establishing the protocols, but once it is all set, you can simply start the machine and it does its job, while you can walk away and do other things. Reproducibility and consistency of pipetting is another important factor, especially when it comes to increasing sample number as well as processing time. When you have long working days at the bench doing repetitive pipetting steps for hours and hours, you cannot keep the same quality with a handheld pipette over time. The human thumb is a sensitive device, but consistency of automated handling translates itself in reproducibility and decrease of variation. Working in the low microliter range can be tricky. So here you see drops of blood with different volumes from 0.3 microliters on the left up to 5 microliters on the right-hand side. And when you look at the scale below the drops, I know that it is not very good to read, but what you can see is that the drops always have more or less the same size, although they differ so much in volume. And now think about the liquids that you usually handle in the lab. Most of them are transparent, right? And when you're working with multi-well plates, for example, in a PCR or in a cell-based assay, you even have to pipette the tiny amounts of transparent liquids 96 times in a row or even more. Besides low volumes and transparent liquids, the physical properties of a liquid can make it tricky to pipette the correct volume. Aqueous solutions are the easiest ones when it comes to pipetting. I'm sure some of you have experience with other liquid types, for example, volatile liquids such as ethanol that tends to drip out of the pipette tip, or viscous liquids like glycerol or DMSO that does not get in or come out of the tip easily because of its viscosity and stickiness. Another common thing is air bubble formation and foaming, which you might have observed when pipetting a PCR master mix or cell culture media. When pipetting all these different liquid types manually, the right pipetting tool and the pipetting technique can help to transfer the correct volume as accurate and precise as possible. With an automated liquid handling system, you can adjust different parameters of the pipetting step in the software and thus optimizing the pipetting for every liquid type that needs to be transferred. And now it is time for our first poll question. You can participate by clicking on an answer, and I will show you the results right away. So here comes the first question. Why do you consider automation for your lab? What is your main reason for considering automation? And the answers you can click on are: I'm facing increasing sample throughput, I want to improve reproducibility, I want to save time and have the freedom to do other things than pipetting, I have to do a lot of repetitive and tedious pipetting work, or all of the above, or none of the above. And I will give you a few seconds to answer. So again, the question is, why do you consider automation for your lab? And the answers you can click on are: increasing sample throughput, improving reproducibility, save time, I have to do a lot of repetitive and tedious pipetting work, or all of the above and none of the above. So I can see that the answers are slowly coming in. I will wait a few seconds more, giving more attendees the chance to participate. I can already see a clear tendency here, but let's wait a few seconds more because the numbers are still changing. Okay, and so I don't see the numbers changing anymore. I think we can close the poll and share the results with you. So I hope that you can see the results now. So we have 5% that say we are facing increasing sample throughput, about 21% want to improve reproducibility, and the majority, more than 70%, says that all of the mentioned factors are their reason why they consider automation for your lab. So saving time and having to do a lot of repetitive and tedious pipetting work as well. So thank you again for participating. We will go ahead with the presentation now. So with manual pipetting, the largest source of error is actually due to the person holding the pipette in their hand. The operator accounts for 70% of the source of error with manual pipetting. Or the other factors listed here, such as the actual pipette being used or the type of liquid being transferred, additionally contribute to variability with manual pipetting. So taken together, the automation of liquid handling steps is one way to counteract non-reproducibility of experimental data. So after talking about the benefits of automated pipetting in the lab, let's have a look at the possible concerns that you might have. What makes it so difficult to commit to an automation platform? Typically, one of the biggest concerns is the large learning curve that you might have. So your thought process might be, will I need to learn a new language? Will I need programming experience? I don't want to waste time learning something I will never use again. You probably start thinking about how much time you want to invest into learning the software of a new automation system. And if it takes too long to use, you may think it's better to run a process by hand. So taken together, automation can be scary. Software bugs may come up that can make it difficult to recover from. And it can also seem challenging to transition from manual processes to automation. Not only when you think about liquid transfers, but also about the deck configuration, the tip usage, and the details of all of your pipetting steps, including volumes, air gaps, flow rates, and so on. And there may be also concerns about how much lab space is needed for an automation platform. The size of such systems can differ greatly, but for sure, all of them require significantly more space than a handheld pipette, of course. All these concerns are realistic, but depending on the automation platform that you choose, they can be somewhat alleviated. So when considering automation, there are some questions that can be good to be kept in mind, and these questions can be used as a framework to help you making the right decision for your lab. The first thing to consider is sample throughput. So what is throughput in your case, and will your throughput in the lab grow over time? For example, throughput can be, for example, the number of plates processed per week or the number of samples you run in a day. So understanding your level of throughput will help what kind of liquid handler best fits to your needs. The second thing to consider is the level of automation expertise in your lab. If your team does not include automation engineers or experts, your lab needs a very user-friendly and intuitive software. Turnover in a lab is inevitable, making it very likely that at some point a new person will need to be trained on the system. Taking it one step further, how many people will be using the system in total? The more people that will be using the liquid handler in the lab, the more methods and protocols need to be programmed. So this makes it extremely important to think about the usability of the software of the automation platform you are considering. Another consideration when deciding for an automated liquid handler is the size of the system. As I already mentioned, lab bench space is precious. So how much space are you willing to give up? Does the system need any additional connections such as water, electricity, or air supply? Where this may mean that you need to get in touch with facility management, for example, in order to get this liquid handler set up in your lab. The feasibility of accessing these additional connections may alter the liquid handler that is the best fit for you and your lab. The final consideration is deciding on how much your process should and can be automated. Larger liquid handling devices can typically automate all steps of a workflow with additional device integration. But for example, is it a deal breaker for you to carry your sample plates to a thermocycler for doing the PCR? Does your lab really need the cycler integrated into the deck of the liquid handling platform? That is definitely something to think about. The level of integration and automation your lab needs will influence your final automation decision. So let's have a look at some workflows in the lab. Besides increasing throughput with millions of samples, when does automation make sense? The general advantages of automated liquid handling we already discussed: more walk-away time, less hands-on time, therefore higher productivity in the lab. Safety aspects and ergonomics are an important factor as well. In addition, automating pipetting steps can reduce inconsistencies in general, no matter which specific workflow you look at. So here you see an example of a sequencing workflow starting with the primary sample, including nucleic acid purification, library preparation, normalization, PCR, and so on. So all in all, a very long workflow with a lot of single steps and a lot of pipetting work. So let's look at the pipetting steps and the time required for this workflow. Here you see some examples and time estimations for different parts of the workflow. Of course, the hands-on time is very user-dependent, so it's just an estimation. And the most time-consuming steps in this example are needed for nucleic acid extraction with about 500 steps and 2 hours hands-on time. And the winner in this case, or in this workflow, is the library preparation with up to 2,000 pipetting steps and up to 5 hours hands-on time. So the first thing that I think we can agree on is that these two parts of the workflow are the most tedious ones and the longest ones. But what about the other steps here, like PCR and normalization? So does it make sense to automate these things as well? Is it worth it? So let's have a closer look at PCR first. Preparing a PCR includes all the classical aspects of manual versus automated pipetting that I already talked about. You have to pipette very small volumes of mostly transparent liquids in many single and repetitive steps. There is a demand for high precision of the transferred volumes, and I already mentioned that the master mix of a PCR tends to foam and air bubbles are created easily during pipetting. Let's have a look at normalization. So when you do the normalization of samples by hand, it can be a very tedious and error-prone procedure. You look at your spreadsheets, set the volume of the pipette accordingly, and then do the pipetting. And you do that over and over again. Look, set volume, pipette, look, set volume, pipette. In contrast, the automated process is much simpler. You start the robot, import your spreadsheet, start the run, and then the robot does its job and you can do something else. So coming back to my workflow slide here, taken together, considering automation of a workflow, or at least certain parts of it, will require some time upfront for establishing processes and optimizing protocols. But once you are ready to go, it gives you the time and the freedom to do other things and thus increase your overall productivity in the lab. And before I start with the next chapter of the presentation, I would like to start our next poll question. So I'm interested in the applications that you think about that you want to automate. And the things that you can click on here are DNA, RNA purification, cell-based assays, PCR, or NGS library preparation, or others. And again, I will give you a few seconds to answer the question before I share the results with you. And I can see that the answers are already coming in. I will give you a few seconds more. The numbers are still changing. So again, what kind of application do you want to automate? DNA, RNA purification, cell-based assays, PCR, NGS library prep, or other applications? Okay, just a couple of seconds. And I think we can close the poll now and share the results. The numbers are not changing anymore. Okay, hope that you see the results now. So the majority of you, 45%, is thinking about automating PCR. Then we have 22% for library preparation, 18% nucleic acid purification, and 9% is thinking about automating cell-based assays. And then we have roughly 5% who clicked on other applications. That's very interesting. Thank you again for participating, and I will go on with the presentation now. Okay. So, all the benefits I talked about sound good, but does that really justify the costs? Because let's be honest, automated liquid handlers are a serious investment for a lab. So no matter what systems or supplier you look at, there are always additional costs for accessories and consumables like pipette tips, plates, tube racks, and so on. Okay, so let's have a look at the actual workflow costs. We are taking NGS as an example workflow, starting with the extraction and purification of nucleic acids. Considering we have 96 samples, the cost for nucleic acid purification is around 200 euros, mainly for reagents. For the library prep, including quality control, the reagent costs are roughly 5,500 euros. In addition, an upfront invest of around 30,000 euros for the respective instrumentation, like tape station and qubit, is needed. And for the sequencing, the running costs can be up to 50,000 euros, including reagents, flow cell, and software subscription. And for the sequencer itself, the costs can even go up to 1 million euros. Of course, this only applies when you do the sequencing in-house. Otherwise, you need to invest in a service provider doing the sequencing of your samples. And what about the samples themselves? The samples are a cost factor that is not so easy to calculate because it can vary greatly depending on the source and the kind of primary samples that you are using. So, for example, on the lower end of the cost range can be samples from cultured cells or bacteria. Of course, it always depends on what kind of cells and bacteria you work with, followed by different types of samples from patients, food, or the environment. Samples from lab animals and liquid biopsies will be less expensive than samples from the field and solid biopsies from patients. And when we look at samples from tumors, pathogen materials, and very rare specimens, it is almost impossible to put a price tag on them. And this brings me to our last poll questions. I would be interested in the samples that you are working with in the lab. So the next poll question is, what kind of primary samples are you mostly using in your lab? And the answers that you can click on are cultured cells or bacteria, environmental samples, food samples, patient samples, and others. And again, I will give you a couple of seconds, wait for the answers to come in. I will read the question again. What kind of primary samples are you mostly using? Cultured cells or bacteria, environmental samples, food samples, patient samples, or others? And the numbers are still changing, so I will give you a few seconds more to give everyone a chance of participating. Okay, so I think we can close the poll now. The numbers are not changing anymore. And we will share the results for you. I hope that you can see it all. So let's see. Majority of you, 45%, is using patient samples of different nature, then followed by 25% for cultured cells and bacteria. And then we have 8% for both environmental samples and food samples, and then 12% for other kind of primary samples. That's, again, very interesting. Thank you all for participating. And I will go ahead with the presentation. So let's have a look at the agenda again. And let's sum up what we have discussed so far. It makes sense to think about automating workflows when the sample throughput in your lab is increasing, in contrast to manual pipetting, which can be error-prone depending on the technique applied and the tool that is chosen. With automation, you always achieve high accuracy and precision of liquid transfer, since you can adjust the liquid type parameters and program it as needed, and thus achieve higher reproducibility and standardization and consistency in your lab. In addition, software-assisted documentation ensures data integrity, and last but not least, an automated liquid handling platform provides both sample and user protection during the workflow. When considering automation for your lab, a checklist like the one shown here can help to answer the most important questions, like, does the system support my application needs and throughput? Is there enough space on the deck and can it be increased when required? Is the range of volume sufficient and is the system flexible enough for me? Size does matter, so the system you are choosing should match your lab space, and there should be access to all connections that are needed, like water and electricity, and others. And of course, the cost for the automation equipment and services are an important factor in your decision. Same for the usability of software and also the hardware. And all these are very valid questions to think about before deciding for a certain model of automated liquid handling system or for a supplier. So now that we have reviewed what questions to ask when choosing an automation platform, there are a few key topics that are worth remembering. First, the system should meet the needs of flexibility in terms of customization, such as the use of different accessories, different kits, and different protocols. The software should allow you to adjust as needed. Additionally, if your lab requires full walk-away capabilities, the liquid handler should be able to integrate with devices such as thermocyclers, mixers, plate readers, plate washers, or even incubators and centrifuges. And depending on the automation platform that you choose, there should be an appropriate level of application support and expertise from the supplier and service. Um, and once you have all your question answered, you should feel comfortable on deciding what automation platform fits best for your lab. Okay, and before we start with the Q&A, I want to show you an overview of the automation solutions that Eppendorf is offering. Here you see our EP Motion family of automated liquid handling systems, starting on the left with the smallest family member, the EP Motion 96, which is a small semi-automated version of a 96 well pipette. And I will show you in a few seconds on the next slide what semi-automation means in this case. Then we have our fully automated EP Motion models, the 5070, 5073, and 5075, which differ in footprint, the number of deck positions for plates, racks, and other labware, and in the number of single channel and multi-channel pipetting tools you can choose from. In addition, the larger EP Motions, the 73 and 75, the two white machines here in this table, can be equipped with a gripper for transporting plates from one position to the other and for stacking and restacking of plates, and also for transporting other labware. And as promised, here you can have a closer look at our semi-automated solution, the EP Motion 96. Semi-automation in this case means that the pipetting itself and the tip recognition is automated upon a click in the software. The tip recognition does not even require a click, so it's automatically recognized. What you have to do by hand is the load of the tips and the moving of the work table. So you can move the work table up and down depending on what kind of plate there is or what kind of tips you have in the device. Okay, and depending on your requirements and applications, Eppendorf is offering different solutions for automating or semi-automating your liquid handling tasks in the lab. And with this, I'm at the end of the presentation. So thank you all for listening so far. And I think we can start now with the Q&A. So I hand over to you, Adam.
Well, thank you, Jessica. That was an excellent presentation. Yep, so we have a few questions from the audience. If anyone else has a question, please feel free to post it into the questions box, which appears on the top right panel of your screen. Right, so let's get oh, and I should also mention any questions that we don't get today to today will be answered offline by email after the webinar. So Jessica, let's get to the first question. How long does it typically take to get something automated?
Thank you for that question. Well, that depends, of course, is highly dependent on the automation platform or the system that you choose, and also on the workflow or the application that you want to automate. So first of all, there is time needed for installing the system and servicing the system. And then you need time for training and protocol development. And this is where the usability of the software comes in. So, of course, the more intuitive software is, the easier it is to develop a protocol and to establish a protocol. Um, so it is an important factor in automating your methods and how quick and easy that is. So it is highly dependent on what you want to automate and what kind of machine, what kind of system you have in the lab, and what
Hmm.
kind of software, of course.
Okay, thank you. So the next question, I guess this one is relevant to the poll that you did. What applications are best suited for automation?
Mhm. So I think the poll results were the most of you were saying they want to automate PCR. So that's a classical example. Same for library prep for NGS, also cell-based assays. Um, but also simpler tasks than dilutions, normalization, aliquoting. These can all be automated and are very good suited for automating. So basically, um, it's a wide variety of applications, and typically these applications or steps or these applications have a lot of repetitive and or time consuming steps, or require very high accuracy and precision, which is maybe not so easy to keep up when doing it all by hand. Or applications that require better sample management, or labs that require better sample management. Um, these are all things that are good suited for automation. Yeah, so basically it's a wide variety, everything that is very repetitive, very tedious, and takes a long time and a lot of pipetting steps. That's the general answer here, I would
Okay.
say.
All right. Thank you, Jessica. So on to the next question. Can you use a liquid handler for sterile sample dilution or aliquoting?
Um, so when you think about the different devices that I showed you, so when you look at these semi-automated 96 well or 96 head pipettes, these are usually very easy to place inside a laminar flow hood, and also can be operated in a laminar flow hood. So um, yeah, there you have then your sterile or germ-reduced surrounding. When you think about the fully automated versions, well, I can say that well, the EP Motion from Eppendorf can be equipped with a so-called clean cap, which has UV light for decontaminating yeah, the inside of the machine, and it also contains an air filter to filter the air inside the machine. And there's also from other suppliers fully automated solution that are completely, yeah, completely sterile or for sterile handling. And there are also suppliers of very, very big laminar flow hoods where you can place even such a big device than our big EP Motions inside. So it usually does not fit into a standard laminar flow hood because it's simply too big. But there are also special hoods for bigger devices if you don't want to go with a fully sterile automated version or automated machine.
Hmm. Thank you. Um, okay, and what kind of accessories are on the automated platform?
Um, where there are different types of
Mm,
accessories, I would say.
mm,
So we have accessories that can be removed from the decks. So here I would say it's like plates, tubes, magnets, so everything that you can put on the deck and then remove from the deck. And then we have so-called built-in accessories. For example, a heater, a mixer, a shaker. So again, different suppliers have different kinds of built-in accessories, but the most common ones are mixers and yeah, mixers or shakers and heaters. Um, yeah, so this is what we consider accessories. The consumables on the one hand, so the whatever plates or tubes you use, and the racks and magnets, and then the built-in equipment like heaters or mixers.
okay. The next question is quite interesting. Is there a chance of inaccuracy with automation using a software?
That is indeed an interesting question.
Mm,
So in terms of the actual pipetting tool of the automation system, of course, it is important that you get it calibrated and serviced. So I can
mm.
only talk for Eppendorf. And here, when you buy the tools or when you buy the machines, they are coming with calibrated tools and serviced tools. Of course, uh, then you have accurate liquid transfer from the start. Of course, like any other handheld pipette, our pipetting tools for the EP motion need to be calibrated on a regular basis to keep the precision and accuracy. And from the software side, you have the settings for the liquid type, so the different parameters that you can set, and there yeah, you from the software side, it is not possible to pipette inaccurate when you have set the liquid types correctly. So yeah, so there is a slight chance of inaccuracy, I would say, when you work with non-calibrated tools or when yeah, when there's a machine that does not work with tools but with integrated like pipetting channels, you sometimes have to exchange the complete pipetting heads because these are, depending on the supplier, cannot be calibrated. Yeah, so it again depends on the system that you look at or the supplier that you look at.
Okay, thank you. Right, I think we've got time for one or maybe two more questions. Jessica, what volume ranges can the Epimotion pipette?
Hmm. So again, there's a difference between our semi-automated EP-Motion 96 and the fully automated bigger devices. So for the EP Motion 96, the volume range, there's two different versions available for different volume ranges. And overall, the complete range is zero point 0.5 up to 1000 microliter. This is for the EP Motion 96 semi-automated version. For the other three models, we cover a volume range of zero point 0.2 microliters up to 1 ml. And of course, this is depending on the tools that you choose. So we have in total 4 different tools with different volume ranges, and all of them are available as single channel and as multi-channel versions.
Okay, thank you. Right, well, I think that brings us to the end of today's webinar. Jessica, thanks again. That was a really interesting presentation and I think a great discussion too. And thanks also to our sponsor, Eppendorf. And finally, thanks to you, the audience, for taking the time to attend and listen in. Any of the questions that we didn't get to today will be answered by email after the webinar. So until next time, good luck in your research and goodbye from all of us at Eppendorf and Bite Size Bio.